Alright, more packs of foiling. I think we're good on these. I'm not sure. Do you guys want to see this process out? I would love to go through it. Okay, let's do it. So, foil says first. First, which ones are first?
3x and x.
3x and x. So when I'm going to write that out, 3x times x. Alright, and the next? 3x and negative 2. So I'm going to put plus negative 2 times 3x. Plus now the inner 4x, yes. 4 times x. And then last, negative 8. Okay, so now let's kind of make this look a little nicer. 3x times x. 3x squared. Now remember, when we multiplied, when they had the same base, we add the exponents. In this case, both exponents are 1. So that's how we got squared. Now, negative 2 times 3x, negative 6x, plus 4x, that didn't need anything done, and minus 8. Am I done there? In standard form?
No.
Combine like terms, absolutely. 3x squared, negative 2x, minus 8. I feel like I'm just talking to areas here. So is that in standard form? Looks pretty good to me. So, I don't think we need to see this. However, this one does have a little special case. Now when we notice we multiply these binomials, we end up with a trinomial. Well, let's see what happens when we try this one. We all have this one down before I erase it. Okay, so once again, FOIL says first, x times x, x squared. X times 5, which is 5x, so plus 5x. And then negative 5x, or negative 5 times x, which is negative 5x. Negative 5 times 5, negative 25. Okay, so I went through the whole FOIL method. Now what?
Combine like terms. Combine like terms.
Combine like terms. So what do I get when I combine like terms?
0. Okay.
So,
Yeah.
so this is a good question. Do I end up with x? Well, I'm subtracting the 2. So 5 minus 5 is what? 0. And what's anything times 0?
1. 0.
It's 0. That's okay. So, and what's the name of that property that tells you anything times 0 is 0? Zero property, the identity property of multiplication. Or, no, it is the 0 property. The identity is times 1. So, plus 0, do I have to write plus 0? No, so I'm just left with minus 25. So, in this case, there are special cases where we didn't end up with a trinomial. Or here we ended up with a trinomial. Here we ended up with a trinomial. Here we ended up with a trinomial. So, there are cases that they call special, that you end up with a binomial. But nothing changes. You still go through the same process. Any questions on that? Alonzo, I would love to hear if you had a question. So any suggestions on this one? So this isn't a binomial times a binomial, so I don't think FOIL is going to work. It doesn't look like we can do FOIL because in order to do FOIL, we had to do it had to be a binomial times a binomial, and this is not a binomial times a binomial. This is a binomial times a trinomial written on the board. So, any suggestions?
Yeah, we have to distribute.
So, yeah, you can distribute. And let's do it that way. So I'm going to take the whole x plus 1 and distribute it to each term. Okay, so let's start the process. What do I have first? I have x squared. I heard x squared times what? Times x plus 1. Remember, we're multiplying by the whole thing. This whole x plus 1. So now what's my next step? 3x times x plus 1. Negative 2 times x plus 1. So there is a way that we can write it out. Now let's go through the next distributing. So we distributed to distribute again. So here, what do I get? What do I get from here?
X cubed. No.
So
2x squared.
I'm going to write, so I have x squared times x. What's x squared times x? X cubed, absolutely, x cubed. Now why is that? We had the same base and we're multiplying. So that means we do what with the exponents? We're going to add the exponents. So x cubed plus what? X squared times 1. So it would just be x squared because 1 times x squared or 1 times anything is the other number. Okay, so we might not have got that one. Let's try this distributing here. Now we're just distributing. So I'm distributing, what am I distributing here? 3x, so I'm going to distribute the 3x. Now, what do I get for my first term? 3x squared. And that was 3x times x. Okay? So now I'm doing 3x times 1, the next term. And what's 3x times 1? 3x. And what's the name of that property? I said it earlier on accident. We're doing the distributive property, but this is called the, when I multiply by 1. The identity property. The identity property.
She said that.
Sorry, I didn't hear you. Be proud of your answer. So, looks like I'm done with the middle. Now what about this last one? So I'm going to multiply times the negative 2 to each. So negative 2 times x, which is negative 2x. And then negative 2 times 1, negative 2. Name of that property? The 1 times the negative 2 is negative 2. And why is that? The identity property of multiplication. Okay, so now, even though I wrote them in different colors, we can still add like terms. I wrote them in different colors so we can see the steps. So, let's add like terms. Well, I see an x cubed. Do I see any other x cubes? No, so I have x cubed. Now I see an x squared and another x squared. Luckily they're next to each other. So what do I get there? 4x to the second?
No, oh yeah, to the fourth power.
4x to the fourth power?
No, it's 3x to the fourth power. No, squared.
4x to the second.
4x squared?
What is it, 2?
Okay, so when would we add the exponents? When we're multiplying. So here we're not going to add the exponents, we're not going to mess with them. So Alonzo's right. Right on 4 x squared. I'm sure other of you had it, but I heard Alonzo, he was proud. So 4x squared, I added the 1 plus the 3. Now I see x's, so I'm done with that term. Done with that term and that term. So 3x minus 2x minus 2. What are my like terms there? 3x and 2x, or the minus 2x. So what do I get there? I just get 1x, and I can just write x because of which property? The identity property of multiplication. So I'm done with these. Negative 2 doesn't have anything, so stuck with negative 2. So, a really long process to get to this. Now, I'm going to suggest that there's another easier way of doing this. And just to make sure, I'm going to leave that up there to see if we get the same answer. Okay, so I have x plus 1. Can you not see that over there? X plus 1, x squared plus 3x minus 2. Okay, now I'm going to claim that I can take this x and just multiply it by each term, kind of like FOILing, and I'm going to take the second term and multiply it by each term. So let's see what I get when I have that. So what's x times x squared? X to the third. Okay, x times 3x? 3x squared, I'm on this step, 3x squared. Okay, so now I'm going to do x times negative 2. Negative 2x. Okay, so that, I'm done with x now, I'm on to 1. So 1 times x squared. Oh, I forgot the x on that. So 1 times x squared. It's just going to be x squared. What's the name of that property? You were all over it earlier.
Identity.
The identity property, yes, and multiplication, all over it. So I'm just going to end up writing the same thing, but let me make sure I go through each step. 1 times 3x is 3x. Name of the property, Mia?
Identity.
Identity property. 1 times negative 2. Negative 2. Would you like to have that property too? Identity property of multiplication. Okay, so now where are my like terms?
3, 2, 3.
I see 3x squared. Well, let me look at my x cubed. That's my first one. I don't see any other x cubes. So that's it for x cubed. Now, x squared. I see an x squared here and x squared here. So what do I get when I add those together? 4x squared. It's starting to look convincing. The first two terms are right. Now what about my x's? So that one's done. Negative 2x, I see, and 3x. So I get x minus 2. Is it in standard form?
Yeah.
It's in standard form. Now is it the same as this? It is.
Yeah.
So, it's up to you which one you want to do. Me, preferably, and the way I'm probably going to do it the rest of the time, I'm going to do it that way because that seems a little easier to me. But, if you ever get in trouble, just make sure you stick to your basic rules of distributing. Any questions on that? Okay. I even drew nice arrows for you guys, in case I didn't draw them myself. So let's try this one. You guys try this. Ask me if you have any questions. Try this one. had a question, I just wanted to be vague. What area should be good? What do you lost? You want arrows now, crazy. So, I'm gonna show you. Yeah, square. Okay, first thing I noticed is that this does not look like it's a standard form. So I was putting this.
What do you think we need to do? Get it?
First thing I noticed is not a standard form.
Just like your English. Take this. Times out. This isn't half the list to do with problems in this unit.
Okay, so let's go over there. So I'm gonna go with the step I did on the board because I think that's a little simpler. So 2 times 3, 6. 2 times negative 4x, negative 8x. 2 times 2x squared, which is 4. 4x squared. Okay, so I'm done with the 2. Now what about the x's? 3x for the first term.
Oh. Is this works a negative?
I really want to fling you in here.
I think there's a negative on there.
You should do it. Don't do it.
So this is a negative. That multiply, right? Okay, so x times negative 4x, which would be negative 4x squared, yes, negative 4x squared. Do you have a question?
How'd you get positive 4?
How to get positive 4. I did 2, and this is the 1, 2, 3rd step, so 2 times 2x squared. So 2 times 2 was plus 4, and then the x squared. I think you might be ahead of me thinking with this one, because I see 2 of them. Okay, so negative 4x squared. Now on to the last step. So I still have 2 to the 3rd. Okay, so let's get like terms. Let's see a 6. Any other just plain numbers? No, so just a 6. I see a negative 8x. I see a 3x. So I was done with this one. Negative 8x, 3x. So that is a negative 5x. So I'm done with these. So 4x squared and a negative 4x squared. So 4 minus 4 is 0. So I can write plus 0, but I don't think I have to. So done with these. Plus 2x cubed, because it's the last one left. Now am I done?
No, yes,
Got to put it in standard form, right, James? So, how do I put it in standard form? So I'm going to put the x cubed first, absolutely 2x cubed minus 5x plus 6. Great job there. That one looks good. So now we can't get confused because they can write it a different way. Now, how do I actually write 4 squared? What is that?
times 4.
Yeah. 4 times 4. So there's 2 4s, not to be confused. 4 times 4. Now what about x? How can we write that?
X and X.
X and x. So that's just x times x. So that's not hard. Now, some people think that this looks a little confusing. But from that, what can we conclude that we should probably do to this? Distribute. Okay, what are we going to distribute? This is squared, by the way. That's not times 2.
X.
So 1 and 2 into x and 2.
Everything inside.
Everything inside.
I don't
So,
know why I said that loud.
Let's look back. So when it was 4 squared, that was the same thing as saying 4 times 4. X squared, the same thing as saying x times x. So when I have this, x plus 2 squared, what is that the same thing as?
X plus 2 times
X plus 2 times x plus 2. Great job. I must not have asked the question clearly. I'm sure you guys all knew this. I didn't ask clearly. So, now what can I do from here? I can distribute, FOIL, I can do any of the above. So, x times x squared, x times 2, 2x, 2 times x, 2x, and then 2 times 2, which is 4. Add my like terms, so x squared plus 4x plus 4. So, let's not get confused by these squares. That just means we're going to multiply that same quantity twice. Same quantity twice. So, what about this one? Mia, please.
The stuff inside twice.
The stuff inside, that's what you meant by that. I was confused by what you meant. That's on me. 1 minus x times 1 minus x. Okay, so FOIL again. 1 times 1. 1. 1 times x, or 1 times negative x. Negative x. What's the name of that property again?
Identity.
Identity property. You guys are all over it. Identity property of multiplication. What's the identity property of addition? That's when you add plus 0. So there is a difference between the multiplication and the addition. Okay, but anyway, moving on. So I did the x times negative x. So negative x now times 1. Negative x again. Negative x times negative x squared. Or negative x times negative x. Did that one. I'm on the last one. Negative x times negative x. It's positive x squared.
Yeah.
Yeah, which one? Are you guessing or are you asking or telling? Telling. X squared, absolutely. Because we're multiplying by similar bases, we add the exponents. When we're multiplying with the same base, we add the exponents. So now what do I do here? Combine like terms. I must be done now, right? No, what's wrong? Not in standard form. What's standard form then? X squared minus 2x plus 1. And that one looks good. Okay. So, that feels good. Let's skip those for now. I bet you guys won't enjoy that. Alright.